Yeah, fine. See, yeah, good. So anyone else, please let me know if you need mic access.
So how long is this session planned for?
Actually, I'm planning only for 30 minutes.
Okay, fine.
So that it will be actually easy for people to join and leave as soon as possible, right? With being a weekend, right?
Yeah,
So I don't want to take too much of time.
sure, sure.
So I'll start the session in 2 3 minutes. So please give me 2 3 minutes.
Yes, please.
So you can always put yourself in mute if in case you don't want to be heard by others. So anyone else need mic access? Just let me know in the questions. I say many people joined now recently. If you want mic access or a webcam access, right? So that you can just let me know in the questions. I'll give you access so that you can ask me questions in person. Otherwise, you can always write a text message also in the questions. I'll answer them. Okay. So I hope everyone knows Tamil here. So if in case if you don't know Tamil, I'll mix Tamil and English in between. So that please let me know if in case you have difficulty in understanding Tamil in the questions. See, actually, this is a very nice tool to interact with followers, get their input, improve my feedback, say forecast, and improve myself also. It is not only the other way around. So, so let me start the session now, so that people can even see this in the recording. So this is about weather basics. I'll share my screen now. Just go through. I'll run through the presentation first, and the few pages, few important weather links I have. See, I have restricted this session only for 30 minutes. I don't want to extend too long because many people may not be interested. Sometimes it gets boring also. So I'll take another session completely in Tamil also later point of time. So I'll screen share. Okay, let me screen share this. So so everyone is able, Mr. Muralidharan, are you able to see the screen?
Yes, I am.
Weather basics one, right? Okay, fine. So we are going to start more about weather basics. And to understand what is weather is all about, we need to understand these basic components of weather. See, the weather components, right? We generally actually we know about temperature, atmospheric pressure, wind, humidity, precipitation, and cloudiness. See, all these six components actually contribute to weather. So, whether at any given point of time, right, all these six different parameters actually working in tandem. So, to actually give us the nice feel about the weather, whether it is very hot or cold, right? It depends on the six parameters. So, if you have any questions, you can always post in the questions tab. See, there are four types of forecasting. One is long range. Long range is, we generally weather bloggers say long range forecast suggests we have a very good northeast monsoon, right? It is about 1 month to 1 year in advance. We can say next year northeast monsoon will be good or bad. This is a very long range. So the medium range is 1 week to 4 weeks. So medium range forecast will be more accurate than the long range forecast. The short range anyway, right? Right? It is 1 to 7 days, so it will be more accurate than even the medium range. And hazardous weather outlook will be the weather statement given by us or by weather agencies about next 7 days. If in case it is severe cyclones, or say about severe thunderstorms, or heavy rain or flooding, which is nothing but a bulletin kind of a thing, weather bulletin, weather news, which people can actually infer. These are the four types of forecasting generally available for everyone in the world, right? So we are actually going through each and every forecasting before we actually tell you whether the northeast monsoon is too good for this season, whether it is going to rain next week, whether it is going to rain tomorrow, or it is going to be a cyclone next 2 3 days. All these things are classified under four different types of forecasting. See, the weather models we talk about, right? We always refer forecast models. the forecast models is actually most of the weather bloggers follow ECM and GFS. ECM is a European model, GFS is American model. So these two are two different weather models based on two different methodologies. So that we discuss later, because we don't want to get in too much into the weather model details, which I'll take as a separate session actually. So ECM is more considered as more accurate forecast prediction worldwide compared to GFS. So weather bloggers also, we support more ECM forecast than the GFS. Next, moving on to radar, right? See, radar in weather is actually a very great boon to weather bloggers, because without the radar, it's very difficult for us to give you, nowcasting. For example, I always post, right, rain approaching Chennai. Rain approaching Chennai, it is 100 kilometers away. It will rain around 10 p.m. All those things, only based on the real-time happenings. It is not forecast. It is called nowcast. Nowcast in the sense, some clouds are there 100 kilometers away from Chennai. We are able to see that in radar, and we are able to tell you it is going to rain in Chennai by 10 p.m. today. And it's not only seeing the clouds, we have to observe other parameters also before we tell you it is going to rain at 10 p.m. today in Chennai. Okay, so I'll tell you how exactly the radar inference has to be made, or charts has to be made in next slides. See, this is the Varda cyclone, which actually I have taken this image long back in 2016. This is the image we got from radar, which is there in Chennai Mount Road. So it is there in Anna Salai. So this radar actually helps us to have a very good understanding about the current weather. That is, I can say next 3 hours, next 6 hours, up to 6 hours, I can forecast or nowcast whether it is going to rain or not, basing the radar image here. This is the important image for every blogger, every forecaster or nowcaster, to tell you exactly whether it is going to rain in Chennai in next few hours. This is Chennai radar. Okay, if you see this MDS here, right? MDS here is Chennai Nungambakam, or say Chennai Mount, the DBS place. So if you see TPM here, Tambaram, this is Tambaram. This is AVD Avadi. This is actually CGP here, Sengalpattu. So this is Chennai radar. This is 50 kilometers. The first circle is 50 kilometers from the Chennai radar point, 100 kilometers point, 150 kilometers point, and it's like up to 300 kilometers. This radar range is there actually. So this is surface rainfall intensity. Whenever it rains in Chennai, right, we'll see from this page, this is surface rainfall intensity, where it is raining. This is 100. If in case we see red here, right, red, it is 100 mm per hour. It is light blue, right, or green or dark blue, right? So this is 0.1 mm to 13.4 mm per hour. If in case it is white here, right, it is 40 mm. If it is 53, if it is actually green, it is up to 53 mm per hour, up to 66. If it is completely red, more than 100 mm per hour, that is per 1 hour. If in case it rains for that 100 mm per rate, 110 centimeter rain will be there in Chennai. So this is very important for weather bloggers to know where exactly it is raining. I would say it is raining from Tambaram to Chengalpattu stretch, right? I would infer this image. From Tambaram to Chengalpattu, there will be some blue dots. Here now it is raining, right? I have taken this image 1 hour back near Kanchipuram. This is KNP is Kanchipuram. So currently it is raining, light rain. See, in the sea it is raining. It is near Sriharikota. This SHAR is Sriharikota. It is raining here. So based on this image, I can tell you where exactly it is raining. Radar images updates every 10 minutes once. And then actually I have to see the wind pattern. How the wind pattern is actually going to be there in the radar. Then only I can say whether it is going to rain in Chennai or not. For example, this image is, this is surface wind, 0 kilometer surface wind, and then up to 2.4 kilometer from the surface. In the wind pattern, actually it will be actually when the cyclone is around, right? or say any new low pressure is around, actually it will be, the wind will be there up to 6.6 kilometer height. So you can see this is northeasterly wind because it starts from north, tends to south, right? So west. So this one I'll give you how to exactly infer in the next slide. Currently the wind pattern is northeasterly. So if some clouds formation is there in the northeast of Chennai, then it will move towards Chennai city. So every 10 minutes once they take this image and they post it in the website, IMD website. So I have to see the clouds, see the wind velocity, and see where exactly it is raining before I say it is going to rain in Chennai or not. So this is nowcasting. So this is the wind direction actually, and then wind knots. If in cyclone is nearby, right, it will be 75 knots up to, so it will be, this is southeast direction. This dark triangle means actually 50 knots. 50 knots is 58 miles per hour, almost 85 kilometers per hour, 85 kilometers per hour. So they are represented that in knots as well as the miles per hour. So when flag is there, it is 50 knots. So single line is there. Single line is 10 knots. Half line is 5 knots. So I can, from in radar, this symbol will be there. I can say the wind speed is up to 75 knots. That is 86 miles per hour, or up to 100 kilometers per hour, around 120 kilometers per hour. So this is the wind direction as well as the wind speed representation in the radar. So any questions so far, so that I can move to other part of the presentation actually.
So how to ascertain the direction of the wind?
So see here in this slide, right?
Yeah.
This is, it starts from north. The point starts from north, right? So north to, so it is more like northeast to southwest. This direction is northeast to southwest.
Okay.
See, this one is from southeast. This one, right? The 75 knots one. This is from the, starts from southeast, right?
Okay.
Southeast, from the southeast at 75 knots. This one is starts from south. There's no actually that small line, right, at the end of the line. Only one vertical line is there. It is directly from south because the flag is there in the south, right? So 50 knots from the south. This one, right, from the west. From the west at 15 knots. See where this line is there. It starts from that direction, right? So if there's no wind, there's no representation of line, right?
Okay.
It starts from, this one is west. Whereas in radar, this is real time. This is actually not straight. If in case it is straight, right, we can say east. This is northeast, right? North on the top, east on the right. So it tends from northeast. So if you see this one, right, this is more or like east. In the third line, first one, right? Third line, first one is more or less east.
It's more flat.
More flat, right? So this one is northeast, slightly inclined towards west, right? Southwest. So this is very important, right? Radar. Once you infer radar, you can very well know whether I can go to office without raincoat. Okay, as simple as that. Because many people ask me whether I can take a raincoat. If in case they understand how this radar inference is, right, they can very well plan that. See, there are multiple parameters to this actually. Before it comes to your place, the clouds get dissipated also. It's not going to maintain the same intensity. Don't assume that the clouds will maintain the same intensity when it reaches your place after 50 kilometers of traveling, right? It will rain, the clouds will dissipate, all these things will happen. So this is about weather basics about this one first chapter. So you need to understand what are the types of forecasting, what are the weather models, and how to infer radar. These three are weather basics, I would say. To start with, I need to understand what all the weather models, weather blockers are taking all the input. Weather nowcasting radar, we are taking input, and then what are the basic parameters we see? The 6 components of weather we see, right? We see sea surface temperature whenever a cyclone is there. So temperature is very important. Wind direction is important. So cloudiness is important. So and then wind convergence, that I'll take it in next class. What is wind convergence is all about. So I need to understand a lot of parameters. Weather has actually 6 components, but permutations and combinations are multiple, right? We need to see how to infer whether when the temperature SST, we see sea surface temperature at 29 degrees, if the sea surface temperature is more than 27 degrees Celsius, then there's a possibility of cyclone. Cyclone in the sense, the cyclone can actually survive only above this SST, this sea surface temperature. If in case it below 27, 25, right, it won't get that potential heat energy to actually sustain. So those things I'll explain you in later classes. So I'm here to explain each and every weather part, weather components, weather possibilities to you guys. Actually, I'm recording this session. I'm going to post this in YouTube as well as wherever I can, so that I can explain weather to many people. So see, this one, right? This is the current system. We are talking about next week's system, whether it's going to rain in Chennai or not. How we infer this data. So, Mr. Muralidharan, are you able to see this, right? This one?
Yes, we are able to see it. Yeah.
Yeah. See, there are n number of possibilities here. See, this one, the system is actually, it is actually low now. It is again gaining intensity, depression now. And then it goes again to, say, 3 circles. All these circles are isobars, we say in weather. I'll explain that later. Just infer this chart. How people are saying weather is going to actually very harsh in Chennai next week. So Chennai, it is here. So it is going to come near Chennai, going to South AP. Then it takes again a route of southwest towards Chennai and moving over Chennai. This is the current forecast of GFS. I won't say this will be accurate. This is going to happen. I'm just inferring this chart. How we are inferring this chart, right? This is a weather chart. Most of the weather bloggers infer this chart to post in info. This will be available for actually 15 days. I can forecast up to 15 days, but most of the time it will be actually won't be accurate. This dry year we talk about in weather, right? See, this is the dry year chart. See, the brown is dry year. Okay, the green or blue, right, represents actually moist year. When the system is coming near Chennai, it is driving the dry air away from Chennai space, so that it is going to rain Chennai. At the same time, there's a dry air actually coming from around the circulation entering into the center. That's the reason why this forecast says this system may weaken before crossing the coast. You can see the dry air around the center. It centers through the southeast direction towards the center. So there's a possibility of system weakening, but system sustaining because it has very good strength. So all these parameters has to be taken into account in weather. So weather forecasting is not easy job. Try to understand the weather basics first. So once you are able to understand the weather basics, then it is very easy for you to actually understand how the parameters, how the charts, and what all things you need to infer. Actually, we don't infer every parameter from this chart. Okay, we'll try to see, we compare with multiple models to see where the dry air is, what is the other parameters which is actually contributing to the system before we decide it is going to rain in Chennai or not. So this is the current radar. So this is the current radar. If you see, this is the current radar. From here, this is Mahabalipuram. from here to here, we can see the clouds are there. Okay, so this is Sri Perumbudur. This area is Sri Perumbudur. It is raining currently in Sri Perumbudur. So we have to see the wind direction now. It is actually, it is not actually, the wind pattern is not great. Wind direction, wind is actually very low. The steering winds, we say, wind speed is very low. So the steering is very weak. That's the reason why actually the clouds are moving very slowly towards the coast. It's taking a lot of time to move near the coast. If in case the wind speed is high, right, it will move within 10 minutes. 10 minutes, it can travel up to 50 km per hour. So here this one represents 40 decibels. So this clouds can give you up to 30 mm if in case it is going to sustain when it nears the coast. This one may reach near Sengalpet to Tambaram stretch again. The other one, right, from Sriharikota to our Ponneri, there's another clouds array of clouds actually moving towards that area. City is relatively dry today. The rains are very scattered here. So there's no continuous rain is going to happen tonight also. Maybe scattered showers here and there in Chennai. So this is the weather chart inference. See, this is the actual surface area intensity of rain. Sri Perumbudur, I told you, right? Sri Perumbudur is raining. Ponneri, north of Ponneri to Sriharikota, it is raining. From Mahabalipuram to actually to Kovalam, rain possibility is there, but it is raining at the east of these areas over the open seas. So this is how we infer charts. So any questions you can ask me in the channel, or if you want mic, I'll give you mic also. Just let me know. So I'll project some questions. I'll answer them also. So Mr. Syed has asked, what exactly does humidity mean? Humidity means the moisture content in the air, right? So that contributes to actually cloud formation. Plus, if in case for dry wind is there, right, then it will fall as a dew or mist. So humidity means the water content available in the air. So is MGO supporting for next system? Yeah, MGO support is there for next system. That is the reason why we are able to see the westerly wind, westerly burst, we say, from equator to the system. The flow is there. So let's see. Sir, dear sir, from where we can get these images? These images, I'll send you all the links also, by the way, where to get exactly the links, where to get these images, as well as the weather model links, all the links. I'll put this as a course. I can even publish it in the Trainer Central so that anybody can view this. You can always share this with your friends or whoever it is. So any other questions before we actually conclude this basics, weather basics?
So before a system develops and it's time to cross the coast, like whether as a DD or a cyclonic storm, right? So when can you be sure, like this is going to be a system of this intensity and it's more likely to move in this direction and it's going to have this impact?
See, weather, right? So every 3 hours there's a change. See, that is the biggest challenge every weather blogger faces today. So if you ask me about Varda cyclone, when it crossed in Chennai on December 12th, 2016, before 6 hours before landfall, the weather forecast suggesting it will weaken before crossing the coast. but it never weakened. It instead it strengthened and crossed the coast. Okay, so uh, there's a big change happening every 3 years when the system is near the coast. They cannot even say it is going to cross near Chennai at this point. When IMD is actually now improving a lot, they are giving us better forecasts in terms of the uh, landfall place. But nowadays, right, after this month, right, very difficult for weather bloggers, everyone to give the correct forecast. So we are supposed to follow that every 3 years. If somebody is posting 1 hour, one week back and saying it is going to rain in Chennai next week, means it is going to fail every time hereafter. As simple as that. So that's the reason why we need to actually follow the latest post in the Twitter, so that you can get the right information.
So GFS is forecasting like it is going to go a little above Chennai or over Chennai itself, whereas ECWMF is forecasting it to go to Pondicherry. So there is a big gap, right? Like as you've said in one of your posts earlier, which I am following, even a 50-kilometer gap is a huge gap in terms of weather.
In terms of cyclone, or in case of in terms of more than a well-marked low pressure area system. If it is a low pressure, right, it will rain widespread across Tamil Nadu. If in case a depression or say deep depression or say cyclone, right, the landfall place and the type of cyclone, whether it is a spiral type or a CDO type. CDO is actually, it will have all the clouds wrapped inside the system. It won't be widespread rain. It will rain only in the 50-kilometer circle or 75-kilometer circle. That's all. Okay. Only after crossing, after weakening, then full effect rain will be there for Chennai or other regions wherever the convergence is there, wind convergence is there. So we cannot even say. So this if the system is north of Chennai 50 kilometers, there's no guarantee that Chennai will get rain. We need to see whether the system has a southern rain band very stronger or northern band rain very stronger, whether wind convergence is supporting all these parameters. So that's the reason why we are finding it difficult to actually tell you in front saying that it's going to rain in Chennai when a cyclone is not yet formed. So there's a big difference now. They converge at 48 hours before. ECM and GFS, they'll come to a consensus, common consensus, only 48 hours up to 78 hours before that.
Yeah, I've seen that in the previous system, which dissipated in the sea at the sea itself.
Yeah.
Right, it took a lot of time before these two models can had a common prediction.
Right. Yeah, you're right. See, every system is unique, by the way. So we have a lot of learning from each and every system. Weather bloggers, the database we have, right, in terms of tracking each and every system. We actually gather a lot of good knowledge about the system, and we see what all the things we have missed to actually take into account. We'll actually take those parameters into account in later point of time. So for the next system, so each and every system is unique. So if okay, somebody's asking some question. Sir, next weekend we are going to plan with family and kids. Polama, it will be raining there also. I would say rainy season, right? Rainy season, it is not recommended. Yelagiri are relatively, it's not hill station, but anyway, it is near Vellore. I would say the rain impact will be there if in case the system crosses near Chennai or below that latitude. So it's better to plan after 3-4 days, not now. Does cold air from north would weaken any system in Bay of Bengal? Yeah, any cold air from the north would weaken any system in Bay of Bengal when it nears the coast. When the cold air, actually dry air enters the center of the system will be actually dissipated in 2 hours. Even very severe cyclone having 100, 150 kilometers, 120 kilometers per speed, right, will get dissipated in 1 or 2 hours if in case dry air enters the center of the system. It will collapse the entire system. Whether this December we will get enough rains. We are supposed to get rains. See, weather blogger, we are projecting that it will rain for next 15 days. There's a very good rains for Chennai. See, the cyclone pattern, right? If in case it actually going to cross like Kaja, right? Chennai is going to be left dry. Only Delta will get rain. If in case it goes to Nellore or Ongole in AP, right? Chennai may not get rains. So we hope it will get enough rains for Chennai. Can you send us explain wind velocity chart again? Okay. See, the wind velocity is again, this is a surface wind. This is 0 kilometers is a surface wind. 1.8 kilometers up to 1.8 kilometers wind is actually there. Wind is blowing. Currently, the wind is blowing from, it is actually blowing from northeast to southwest. So the direction is northeast to southwest. This one, right? The third line, first one is east to west. So this is at 8:30 this is a GMT. All the timings here are GMT timings. So if it is 8:10 plus 5:30 hours, we are supposed to add to the Indian time to get the IST. So this one is again the flat one is east to west of 10 knots, less than 10 knots, 10 knots. So it is 10 knots because only one line is there. It is 10 knots. 10 knots is equal to 1.85. It is 18 km per hour. Wind speed is there. So only 10 knots. All this wind representation is 10 knots. So 1 knot is 1.85 km per hour. So it is actually 18 km per hour. Wind speed is there till from surface level to the 2.4 kilometers height from the surface. So I don't know what exactly to explain here, because if in case you have any questions also, we'll take it offline. If in case you can send me a DM so that I'll explain you in a better way if in case I'm not able to give you the right answer here.
So sorry, even if I am repeating also.
Okay.
So how do we determine the starting point to say it is from east to west?
Yeah. The starting point, see this one, right? The first one is come north. It is come more or less north, right? The first one, uh, 1 right? 0.6 kilometer is complete, more or less it is north. North to, because the 10 knots symbol is there here. It is north to south, more or less north to south. It is not exactly north to south because it is not straight line. It is a slanting line inclined towards east. Whereas the third top one, right, is completely east to west, 10 knots. This line represents 10 knots because they have to, starting point is the line, the smaller line, right?
Okay.
10 knots representation is there, east to west, because this is east, this is west, this is north, this is south. This is how we represent them any maps, right? So
yeah, so that line is always taken as the starting point for the wind direction. It starts from, okay,
it starts from northeast to this one, right? This last line, right? This is more or less east. We say east northeasterly because more inclination is towards east, right? This one, right? This is northeasterly because more inclination is towards north. Right? The first one is more inclined towards. See this third one. It is more or less straight line. Complete. It is northeast, but more north to south. Here, see, that's the reason why we need to see the wind circulation pattern, right? Since the dry air from north means, right, last week when it was very cold, completely this straight line, almost straight line, starting from north to south. Now the easterly winds are coming, so it is turning to northeast. When the wind pattern is very strong from the sea, it will completely turn to east to west.
Yeah, thank you.
Yeah, okay. So Can you share the PPT? Yeah, I will actually put this in the course. I will share the course itself. So upcoming system will be intense as Varda. Maybe, may not be. We cannot say now. So there are chances of 20-30% as intense as Varda, but forecast models are suggesting it might weaken before crossing the coast. We need to wait and see. Can you open IMD website, explain latest data? Since I joined bit late, missed intro. Okay. I would say it take more than 1 hour now. It is almost 40 minutes now. So if somebody wants to leave, they can leave always. So this is the latest radar. So if you see right here, intense rain approaching Mahabalipuram to Kovalam. It is moving from east to west, more or less east to west. At that time we see the wind pattern. Now it is more, see, the surface winds are more east, northeast to west, southwest. So this is the direction we see. So this rain is going to, these clouds are going to move from sea to land. It is going to cover near Kovalam to Mahabalipuram. Next 30 minutes or so, it is going to rain heavily in the Kovalam to Mahabalipuram stretch. Here, Sriperumbudur, it is raining. Ponneri to Sriharikota, it is raining. So easterly winds moves the clouds from sea to land. So because wind is more easterly to westerly. So we are northeast monsoon, right? We are getting winds from the east. So this is actual rainfall, surface rainfall. This place it is raining. This one is just clouds. Okay, this is a long range. This is a shorter range. This one is sea surface rainfall intensity, where we can see the intensity of rain almost 20 millimeter per hour. It is raining in the sea. So, okay. Is the wind direction same across India, or we need to look for specific wind pattern for Mahabalipuram, Sengalpattu? Wind direction is not across India. It is not even across Chennai. So wind pattern actually vary from Sengalpattu to Mahabalipuram. It can be even easterly to westerly in Mahabalipuram, Sengalpattu region. In Chennai, it is northeasterly, easterly. So it only 50 km, only that region, only that place is important. So we are supposed to see the complete wind convergence chart to know where exactly the wind pattern. Otherwise, see the respective radars of the city. If you see the Sriharikota, right, it will be different wind pattern by itself. So Sriharikota, it will be different wind pattern. So if you see, this is the wind pattern of Sriharikota. I share this. This is the Sriharikota weather radar. The wind pattern is different from Chennai radar. Sriharikota and Chennai are 80 kilometers away. So the wind pattern is different compared to Chennai radar, Chennai region. So it depends on the wind pattern in that region. It is not common across India. Currently, is the dry cold air wind present? So currently the dry cold air wind is not present because I'm feeling very it's sweating for me, sitting in even a room where the fan is running in 4 speed 4, it is sweating. Last 21st right, I switched off my fan. Even after that, it is very cold. So if you feel that sweating factor, right, the sweat factor, you can see the wind, cold air is there or not. The cold air is not there now. Can you explain the concept of La Nina El Nino? I'll take this as a separate class by itself. There are two different parameters where the ocean temperature is high in Pacific Ocean. Based on that, they decide La Nina El Nino. So I'll actually give a separate session for this. So based on that, the wind actually based on the La Nina and El Nino, it's going to impact our monsoon also. So separate session I'll take on this. So I think that that's all from the questions. See if anything I have missed, right? I can answer that in Twitter. Thank you guys. Thank you for joining. It's nice talking to you. People actually are answering questions. So I'll continue to do this for many such sessions, even Tamil classes, complete Tamil classes also. Let's see. Thank you guys. Mr. Moderator, any feedback you have with respect to this one?
Yeah, first of all, thanks so much for the initiative. And it's not many people would like to share their knowledge that they have gained over a period of time, and it takes tremendous amount of courage to share the knowledge that you have gained. So a big thank you to you. You guys are doing a wonderful job. So thank you so much. It was very simple, easy to understand. So expecting more sessions with you. Thank you so much.
Yeah, thank you, sir. Thank you so much. So it was great talking to you and the entire team. Thank you guys.
Thank you.
Yeah, thank you.